Hello class, welcome to our second lesson dealing with section 10.4, which deals with compound events. We're going to look at some of the definitions that we were supposed to look at for our homework from our previous class period. Also make sure that we understand what they mean and how to represent them, and also how to find some probabilities of what are known as compound events as we look forward to this lesson. Before we look at today's lesson though, the first thing I would like to look at is just dealing with some volume and surface area review. So right here we have a rectangular prism. It has side lengths of 7, 9, and 4 yards as the length, width, and height. Notice that there's some extra numbers here that you don't necessarily need in order to be successful on these questions. So the volume here would be the 7 times the 9 times the 4 because it's length times width times height, and that would be 252 cubic yards. To find the surface area, remember it's two of the top and bottom rectangles, two of the front and back, and two of the side and sides. Okay, and that's how you would be finding the surface area. And notice these numbers are pretty close, 252 and 254, but notice that this is yards cubed and this is yards squared. So really, even though the numbers themselves are close, they're really not close at all because they're really not related in terms of their units. Okay, a sample space. You're supposed to write down the definition of a sample space from yesterday, but a sample space is a set of all the possible outcomes of whatever can happen in an event. It's more of a list idea, so you have to list out all the options, not just say how many there are. So for example here, this has a menu combos like at a restaurant. So you have 3 sandwiches to choose from and 4 side items. So it says find the sample space. Now for a lot of people, the easiest way to find a sample space is just to make what's known as a tree diagram. So notice you have grilled chicken with fries, apples, salad, and soup. I do the same for hamburgers, fries, apples, salad, soup, fries, apple, salad, soup for the cheeseburger. The issue is that tree diagram is not the sample space because it does not list out all the options. So really all the options are grilled chicken with french fries, grilled chicken with apple, etc. And you go down the list, okay, to find all those options. This piece on the far right is the sample space. Now I'm totally fine, and I think any teacher would be fine with you abbreviating things. You want to be careful with your abbreviations though. For example, you can't do salad and soup both with S because then you don't know which is which. So when you're dealing with those situations, that's something that you want to think about. Now the question is sample space, then it would be the list of these options. If the question is how many combo meals can you make, that should be more of a fundamental counting principle idea where you just take 3 options for this times 4 times this one, and 3 times 4 would be the 12 options. Make sure you're very clear. Sample space is the list of all the options, what are the options, and then combinations of how many would be a number as your answer. So the question on the last slide just dealt with what's known as the fundamental counting principle. This is the second term that I asked you to kind of make sure that you understand as we look at these examples. The fundamental counting principle is just a multiplication idea. If you're trying to figure out how many outcomes are possible, if you look at this bullet point on the right side, it's very helpful to use the fundamental counting principle. If we need to know what are the options, then this idea really doesn't help us that much. But if we go back here, this 3 times 4 right here is the fundamental counting principle. How many options for this times how many options for the side items, and I multiply that together, and that's how the fundamental counting principle works. They use letters M and N just because it's used in probability sometimes that way. The fact that it's M and N is irrelevant to the situation. Next one is roll a 6-sided die and toss a coin. Find the sample space. That's a list. So notice here I did 1 through 6 with heads. So 1 heads, 2 heads, 3 heads, etc. And then same thing with tails. 1 tail, 2 tail, 3 tail, etc. How many options are there? I could either add up all of these from the sample space. I could just count them out. That would be the easiest way to find it in terms of if you've already done the sample space. Long term, the easiest option is the fundamental counting principle though. So there's 2 options for the tossing of the coin, 6 options for the die rolling, and 2 times 6 would be 12 total options that there are for the dice, for the die roll and the tossing of the coin together. A compound event is the third definition that you need to make sure you understand. A compound event is that consists of more than one event, so 2 or more. So think about compound sentence, like 2 sentences put into one. You can still use the fraction idea, and we'll look at some of those ideas as we deal with this first example. So the compound event would be something like this. What we just talked about was rolling the 6-sided die and tossing the coin. Find the probability using the sample space of rolling a 5 and tossing a tail. Now, the easiest way to look at that is just to look at this list and say, well, how many fit that category? And there's only one of them. Okay, toss that number and get a tail. There's only one of those 12 options that work. And so really what I'm doing is using the sample space from that previous slide and saying, well, there's one option out of the 12 that fit. Rolling an even and tossing heads would be a 2 in a heads, 4 a heads, and 6 with the heads. And that would be 3 out of the 12. Notice I still simplified that down to be 1/4. Last one, number greater than 4 and toss tails. Well, it could have been a 5 or a 6, and that would be 2 of the 12 ways, and that simplifies down to 1/6. Another option that you can use, which you'll see long term, which will be a lot faster, is to use the idea of the fundamental counting principle. Basically what we do here is say, well, how do we find the probability of rolling a 5? Well, there's 1 of 6 options that roll a 5. How do you find tossing of a tails? It's 1 out of 2, and you multiply those together. Notice I get the same 1/12 answer as I would have got by using the sample space. In this case, it doesn't really matter which option you pick because they're about the same difficulty level, but with larger sample sizes, the idea of multiplication is going to be a lot faster. This one says roll an even number. There's 3 of 6 numbers that are even, and then toss a coin and get heads. So it'd be 3 out of 6 times 1/2. This ends up being 3 out of 12, which simplifies down to 1/4. We could have also simplified the roll and even down to a 1/2 times a 1/2, and that would be another way to find that answer. Toss a number greater than 4, that would be 2 out of the 6 options because you could get a 5 or a 6, times 1/2, and you get 2 out of 12, and that simplifies down to 1/6 because you could have cross-simplified the 2's here to get an answer of 1/6. The idea of compound events, what I want you to make sure of is you're writing your work similar to what's shown on here. What we shouldn't see is just the 1/4 or the 1/6 answer. We want to see the fact that you have compound events here. So you have the multiplication of the first event times the second event to equal the final answer. So make sure you're working on that as you look at your homework. The next question is a little strange, so let's make sure we're paying close attention. It's toss a coin 3 times. So here's the easiest way to find the sample space. It's just do the diagram idea in order to figure that out. So for example, if I toss the coin and get tails or heads on the first toss. If the first toss is tails, then on the second toss I could get heads or tails. So notice tails and then heads or tails. And then off the second toss I could also get heads or tails. So I just go and keep branching out as much as I can. And then to find the sample space, you just kind of follow the paths. So notice here, heads, heads, heads. That's this one. Heads, heads, tail. That's this one. Heads, tail, head, and head, tail, tail. I just literally go down all of the different types of routes that are possible. So really there are 8 different options here. A lot of people would say 6 because 2 times 3 is 6, but there's 8, and here's why. How many options are there for the first toss? 2. How many options for the second toss? 2. How many options for the third toss? 2. But it's not 2 plus 2 plus 2. It's 2 times 2 times 2. And so that's why there's 8 options. In this case, it's going to be easier just to write the sample space out because if the question is find the probability of getting 2 heads and 1 tail, using the sample space, here's what we'll find. Here's 2 heads and a tail, there's 1. Here's another 2 heads and a tail, that's 2. And then here, 2 heads and a tail, that's 3 of the 8 options. So don't assume it's 1 out of that group because there may be more than one way to get the final outcome of 2 heads and 1 tail. The probability you get at least 2 tails if you just count them up. So 2 tails, here's 1, here's 2, 3, 4. And that would be 1/2, which kind of makes sense in 3 tosses. Half of them should have more heads than tails and vice versa. But again, there's different style of questions. What's the sample space? How many options are there? Okay, what's the probability? We could do the idea of compound event. This question, because there's some overlap, I would suggest doing the sample space and then figuring out the probability from there. Okay, your homework today is 9 through 11 on section 10.4 along with 15 through 28. These questions shouldn't take too long, but you have to read the directions. If it says find the sample space, it should be a list. If it says find the number of options, that can be a lot faster, but you have to show your work about how you got to that answer. Okay, something like these questions here, you got to make sure you show the fractions that you multiplied together. Even if it's something basic like this 2 times 6, I want to see that 2 times 6 so that we both understand that we know what we're talking about, that there are 2 options for the coin, 6 options for the die rolling to get to the final answer of 12. Have a good day, everyone.